Everybody, this is Kubernetes SIG Architecture meeting for April 4th, 2024. Looks like we have a few agenda items here today. So first up is Sergey.
Well, John, are you sharing the screen? If you don't mind opening. Yeah.
It's not showing?
No, it's showing perfectly. Just I wanted to, if you can switch to agenda instead of. Okay. So yeah, I'm here. It's an email sometime a few days back about proposal to form work group serving, and this is just in-person attendance of different SIGs, explaining what it is and gathering feedback. So over time, we discovered that like right now there are many generative AI workloads which is being run on Kubernetes, on different flavors of Kubernetes. And what we discovered is that there are many problems how those workloads being run. There are certain limitations that needs to be worked around. There are certain concepts that not quite supported. And we wanted to follow the same pattern as the working group batch did when they formed this working group batch to solve a specific problem, gather scenarios, influence SIGs, and even like creating their own sub-projects. This is what we want to do with serving as well. We've been considering joining batch working group, but it's not quite fitting, and a different set of people will be participating. So making it separate looks logical. Mostly to just concentrate on specific scenarios and increase velocity, plus get different set of people joining this group. If you haven't read this document, we've been concentrating on inference workloads. We would concentrate on inference that is like request-based, not like batch inference. Like batch inference is a different story, and probably working group batch will be addressing those. We will be looking, like if you scroll a little bit, there is a link to use cases, which is another very interesting document. It's kind of high level explanation what is not working in Kubernetes. Yeah, it's on the screen. If you can open it, please, John. It talks about use cases that we want to fix in batch or in serving. And I think out of all those use cases, what we will be concentrating first is multi-host inference, when you need to schedule all the pods together with certain affinity, with certain on specific nodes, and then you need to react very special way when one of them goes down. So this is what we, and also we need to schedule them super fast, and like latency should be addressed as well. This probably will be one of the most demanding, most asked for solution. This is what we probably concentrate on, but there are many other scenarios and use cases that we want to address, and those are around preemption of workloads. Like let's say you have less important workload and more important workload, or maybe a shorter time workload. How do you preempt longer term workload and like schedule something instead of it on the same node using the same GPU or like other accelerator? Then when it's completed, you switch to something else. This is quite common scenario for test and development. And we see the demand for it a lot because hardware are just so expensive. So yeah, this is basically overview. I don't want to go into like every detail on this document. So if you have any questions, please.
Thank you, Sergey. Maybe before we jump into questions, so Sergey and I are each proposing a working group, and we just came out of SIG scheduling, and I think it was useful there to kind of talk about each and then allow questions to cover both, because some of the questions tend to be around like, what's the difference? So the working group that I'm proposing here, the email, I called it accelerator management, but based on the feedback in the email, we shifted to the idea of device management, which is what it was anyway, but the initial focus is on really on accelerators. And the idea here is a little bit lower level than the pieces that Sergey's talking about. So the the um, existing resource model within Kubernetes with device plugins and extended resources allows like whole consumption of GPUs. And there's some tricks you can play to allow a little bit of sharing of a GPU, but it's very limited in sort of the expressiveness and the ways in which you could do that. And especially as GPUs get larger, and you look at serving workloads. So when for batch workloads, usually, or for like training workloads, usually consumption of whole GPUs and even whole machines and all the GPUs on them is typical. And so this hasn't been a big issue for training. But when we start to look at inference workloads, there tend to be more variety of workloads. Each one, they look a little bit more like web serving in that there's individual requests that are coming in. And you may be able to get away with smaller portions of these very expensive devices with different types of applications doing inference on the same cluster. And so one of the things we want to look at is can we extend the device model, or rather the device model, the device plugins, the resource model, to enable better sharing and therefore better utilization of this expensive hardware. And then that extends a little bit further based on the use cases into things like topological considerations, both inside the node and between nodes, because a lot of times a particular workload might need, for example, both a GPU and a NIC, but they want that NIC to be attached to a specialized network for inter-GPU communication. They don't want to just use any NIC because if they're far apart inside the node, like on different PCI routes or something, then like you will have performance impact. And so eventually, I don't know that it's going to happen in 2024, but eventually we want to extend that functionality down into that level. This has been served so far out of workgroup batch with the DRA caps that have been implemented, which originally in 126 were implemented in a very flexible, abstract way that unfortunately didn't provide the data to schedulers and autoscalers to be able to reason about the workloads and therefore take appropriate action. So in 130, we shifted that a bit based on feedback from those SIGs to a more transparent model. It's not quite where we need it to be. And so this working group is really around trying to advance that model so that it can serve the needs of both this work group serving and the work group batch, and other SIGs like auto scaling and scheduling, and of course there's lots of node work there. So the question we got in the scheduling meeting was, well, what's the distinction between these two new working groups? Because we all have enough meetings to go to. We don't necessarily want more working groups, but there is a pretty distinct set of characteristics. Like this is really focused on the device management is really focused on the resource model, the allocation of resources, and aligning those resources in those topologies. And it's sort of like downward looking on the hardware and meeting the hardware use cases and exposing APIs to the workload level controllers so that they can satisfy the higher level use cases. What do I mean by that? Like Sergey mentioned, like this multi-host inference. So the resource model is going to need to change to essentially denote when individual devices and components within a node, what parts of the topology they're in, and then the workload controller is going to need to be able to sort of specify, hey, I need a set of pods with this sort of topological constraint. And so that's sort of a step up, and it's going to use those APIs underneath. So that's how I see it anyway. And I'll stop there and let people ask questions of both me and Sergey. Or if there are no questions, we will just move on to the next item in the agenda. All right. So then all I would do Sergey, if you have anything else to say, I'll just say our next steps for these, for me anyway, is to put out a PR, which I'm hoping to do today, that sort of starts to lay out some of the things and send it to the steering committee, and then they'll make the decision ultimately. But we've had a lot of interest in both of these, so I'll be sending on a PR with respect to the device management. I hope today, and we will plan on meeting for those who are interested in the week after next. A number of us aren't available next week, myself included. So the week after next, the week of April 15th, we'll have our first working group meeting, start to lay out the scope and plan and that sort of thing. Sergey, did you have anything else to say?
No, same idea. We have some time pressure here. We really want to accomplish something soon. So I hope that we can like get to the main scenarios fast and work together to achieve them.
Yeah, with respect to that, just to give a clear picture, like for the device management working group, there was the DRA 126 did an alpha, 130 we did another alpha. There was alphas between there, but like that was significantly different. 131 we're going to do another alpha, but we want to have something in beta in 132, and so we have about 6 to 8 weeks to get the designs all nailed down for whatever we want to be in beta in 132, based on my guess for the next 131 schedule. Anything that's going to go to beta 132 needs to be an alpha 131. So backing that up, we don't have a whole ton of time, which means we have to manage scope, but we want to put those designs together in such a way that we can the additional scope we have can eventually land. So that's the kind of time urgency we're talking about. All right, thank you. Next item, Eddie.
Yeah, I was hoping Peter would be here, but I don't see Peter. But so we're just kind of gauging interest at this point. Peter, I've been talking for a few KubeCons and contributor summits now. Kube Control Copy has a long history of CVEs. It got to the point where we wanted to remove it completely from the command, and the settlement was we'd keep it in, but we would limit it to tar being in the container image for it to be possible to be used. It's not ideal. We keep getting feature requests and different requests. So the thought now has been that we actually want to build a first-class API into the container runtime for getting and putting a file to and from a container. And we've checked with Peter works on Cryo. We've checked with Phil Estes. He seemed pretty interested and willing to make this happen. So I just kind of wanted to check with you all if there's any initial red flags or anything before we start, drafting up some proposals and emails and KEPs and all that.
Chip?
Yeah, my biggest concern with this, when it's come up in the past, putting my security hat on, is all the CVEs that we've seen related to Kube Control Copy have had to do with various kind of path manipulation exploits. This is all on the client side because of the way we use the actual tar binary on the server side. And so my concern is basically if we move it out of the container namespace, that we're opening up the server side to similar path manipulation exploits. For instance, like say I create a symlink in the container and then try and copy that out. Could that escape the container namespace? And so I think ideally a solution would involve actually entering the container mount namespace to do the copy. But I think kind of just in general, making sure that the design has careful security review.
Yeah, absolutely. That's actually one of the first things that Peter and I talked through was we were going to only allow absolute paths, and B, Peter knew of a way to basically what you said, like to root into the container namespace to mitigate that. But yeah, we would absolutely need lots of security reviews and people to look at it who know better than us. But Peter seems to think that we can do it in a secure way. So And Peter's driving from the container runtime side.
Hey, I'm Ronalia. So I think Peter mentioned it to me briefly, but yeah, I'll be interested in seeing some design document on what the overall flow looks like for this one.
Yep. That's next step. Before we wrote anything up, we wanted to gauge interest. So.
Yeah, one other thing to mention here: the current kubectl CP design proxies all the data through the API server, which creates a bottleneck, especially if you're trying to copy pretty large files out of there. That might be another area to look at in design.
That's interesting. I will write it down on our notes. I know that. So I didn't know this before, but yeah, the way all of those like remote executed commands work is, the container runtime is what actually creates the URL that gets handed back to the API server. I'd always thought it was either the kubelet or the API server, but apparently the only return type out of like create and attach request is a URL from the container runtime.
Yeah, it's still it's now proxying through the kubelet as well. The original design was to try and avoid that extra hop through the kubelet, but I can't remember exactly the reason that design kind of didn't end up working out well for us.
So sounds like, yeah, design doc. I mean, obviously security review. I don't have any personally have any architectural, concerns other than the ones Tim has already raised about you guys are working with Node to make sure that anything there is addressed. Yeah, I think that certainly moving away from relying on tar and things like that probably is a good idea for security wise.
Yeah, and I think everyone we've talked to seems like, yeah, that makes a lot of sense. It's just been, prioritizing and getting it done. But we're planning to try to get this going for 131 release cycle. So.
Yeah, are you? I guess it'll come out in the design doc. I mean, you said adding it to the container runtime, but then from an execution standpoint, like what sort of controls on the API server side would you have, and things like that would be interesting to see.
Yeah, this is that I know the client very well. I don't know very little about the the API server and the kubelet and whatnot. So that's where I'm leaning on Peter and any other friends we make that want to work on this.
Okay. That is the end of our agenda. So any other topics? Okay, then I will give you back the 40 minutes of your life that would have been in this meeting. And everybody have a great couple of weeks. We'll see you in 2 weeks. Thank you.